This lesson is Introduction to Signed Numbers, Absolute Value, and Operations with Integers. Here's some vocabulary that we need to go over before we start. The natural numbers are just the basic counting numbers, 1, 2, 3, 4, etc. And it's marked with this weird looking N. Whole numbers is the next thing. And really the only difference between natural numbers and whole numbers is that the whole numbers include the number 0. So the whole numbers are just a wee bit bigger than the natural numbers, and it's marked with a weird W. Integers are negative and positive whole numbers, if you think about it. No fractions, no decimals, so we make that wider around the whole numbers, and we mark it with a weird looking Z. So that's the integers. And then finally, well actually there's two more categories. The rational numbers are numbers that can be written in a fraction form, an integer over a natural number. So for example, -1 over 2. And we say natural number because the denominator really can never be equal to 0, so you can't divide it by a whole number. So those go around the integers. Okay, and rational numbers are denoted by a Q, like that. And then finally, real numbers go around the whole outside here. And they're denoted with a weird looking R. And for example, the number that's a real number is a number like pi. That would not be a rational number, an integer, a whole number, or a natural number, but it would be a real number. Pi is approximately equal to 3.14, but not exactly that. Actually, it's an irrational number. So the real numbers encompass rational and irrational numbers. The last definition I'm going to talk about is absolute value. And it's the distance on a number line between that number and 0. So for example, -6 is 6 units, 1, 2, 3, 4, 5, 6, from 0. It's basically the number without any sign in front of it ever. Now looking on to graphing numbers on a number line. And so what we're going to do is we're going to graph the numbers, and then we're going to say the most specific classification of number it is. So let's take a look at this first number. Is -4 2/3. Now this number line has no 0 representation. So before we do anything, we should put a 0 representation on the number line so we know where we're going. And so of course this would be 1, 2, 3, 4, etc. And this would be -1, -2, -3, -4. That way we have some kind of starting point to where we need to graph. Well, -4 2/3, well, that would be -4, almost -5. So right about here, I would say -4 2/3. Now this is considered a rational number because it can be written in fraction form. So this is considered rational. Okay. -3 is right here. I'll write -3 above it again. And the most specific for -3 would be integer. -1, I don't know why I did that one, but here we go. -1, again, would have a classification of integer. 0, the most specific classification would be whole number. 1 2/3 would be right about here. And the most specific classification of 1 2/3, again, would be rational. Cool, we're done with that. All right, number 2 says we have to insert a greater than, less than, or equal to make the statement true. Lots of people get confused between which one's greater than and which one's less than. I always remember the less than because it looks kind of like a smushed L. So it's kind of like a smushed L. So if we want to do to make this statement true, having $88 is way better than owing $12. So 88 is clearly greater than negative 12. And another way to know which sign is good here is that the bigger side or the big mouth of that opening goes toward the bigger number. Some people do this alligator thing, like the alligator wants to eat the bigger number, blah, 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 but you know, it's good that way too. The absolute value of negative 5 is just 5 because negative 5 is 5 units from 0. The next thing is we're going to do the rules for adding integers. If the signs are the same, add the absolute values of the numbers and keep the signs. If the signs are different, subtract the absolute values and keep the sign of the number with the bigger absolute value. My trick is to think about money when you're doing this. A positive number means you have the money. A negative number means you owe the money. So if we think about it this way, I owe you $11. I owe you $9. So I still owe you a total of $20, which follows that first one that says if the signs are the same, add the absolute values of the numbers. The absolute value of negative 11 is 11. The absolute value of negative 9 is 9. I add those numbers up, and I'm going to keep the sign of the numbers, which I did. I kept it negative 20. The next one is 11 plus a negative 9. Now these signs are different. So we're going to subtract the absolute values. 11 take away 9 is 2. And we're going to keep the sign of the number with the bigger absolute value. 11 has a bigger absolute value than negative 9. So my answer is going to be 2. But if you think about it in terms of money, you have $11, but you owe 9. So you still have $2. Now, the rules for subtracting integers are very similar to adding, except you have to do one additional thing when you subtract. Subtracting is the same thing as adding the opposite, okay? So we're going to change the subtraction problem to an equivalent addition problem if needed. In other words, sometimes you can just subtract and you just know the answer, but other times it's more confusing and it's easier to write it as an addition problem. And this second piece says 3 take away 2 is 1, and we know that. It's the same as 3 adding the opposite of 2 is negative 2, and we get 1. And then we can say this mathematically. So for the next one, we're going to subtract the integers by first changing the subtraction to addition problem and then answering it. So here's the deal. We keep the 4 the same, change the subtraction to adding, and this last piece, we have to take the opposite of that number, which is 5, and we get the number 9. 4 plus 5 is 9. So you can think about it as having a subtracting and then a negative. They will make a positive. Two numbers, two negatives make that positive there. And then B, I can rewrite it. 6 stays the same. This subtraction changes to an addition, and the 7 takes it and becomes a negative 7. I'm doing the opposite of that. And we get negative 1 because I have $6, but I owe 7. So I still owe $1 because I'm giving you a whole $6, but I still owe you another $1. Lastly, we're going to do the rules for multiplying and dividing integers. These are the two rules. If the signs of the two numbers are different, the result is negative. Let me show you the deal with that. Let's look at example 6 here. Let's suppose I lose $15 a week. And I do that for 5 weeks. Well, if I think about it, I'm losing 15, and then another one, and then another one, and then another one, and then another one. So altogether, I've lost $75. So a negative times a positive is a negative. If the two numbers have the same sign, the result is positive. Now it's wicked easy to see if the two numbers are positive. 4 times 5 is 20. But what if the two numbers are negative? Let me see a scenario here, like negative 4 times negative 5. Well, I claim it equals a positive 20. Now why? Well, let's say I go on a diet and I lose 4 pounds each week. Okay? Then 5 weeks ago, I was actually 20 pounds heavier than I am now. Negative 4 times negative 5 gives me a positive 20. Negative times negative is positive. And the same goes with division. So if I do negative 45 divided by a negative 5, that's going to give me a positive 9. Now let's look at this last one. I just snuck it in on you, and it says the sum of a positive number and a negative number is always negative. Well, if I think about it, if I do a positive 16 plus a negative 8, that gives me a positive 8, which is not a negative number. So this is false. So that's the end of that. So we have to kind of think of what are we adding, are we subtracting, are we multiplying and dividing? And that's all well and good, but the rules kind of mush together sometimes. So just take your time, ask lots of questions, and now start the My Math Lab homework on this lecture. Good luck.